Hi everyone, this is Jeff Mankowski welcoming you back to the Maverick Statistics channel. In the last video we were talking about the Chebyshev theorem, and we found out Chebyshev is pretty cool because it works on any data set regardless of what's inside the data set or what the distribution is like. The downside is that the theorem is not too approximate. We have to keep using a minimum percentage or saying at least this percentage of data is going to be between these two numbers, so it's not giving us a very accurate estimation. But again, that's because we don't really know anything about what's inside the data set, so without knowing much, we can't get very precise. So it's going to turn out that as we get more intel on what's inside that data set, then we can do a lot more with our precision. In particular, if somebody tells us our data set is bell-shaped, then we can use what we call the empirical rule. And the empirical rule tells us basically the same kind of thing as Chebyshev, but we get more approximate percentages out of it. And the second reason why we like the empirical rule is because it gets us to z-scores and standardization, which are really important in Statistics 101. So what we're going to do is go ahead and bring up a screen here. And we've got an example on the bottom of the screen that we'll get to shortly. What we're first going to do is write in what do we need to know to use the empirical rule. So let's go ahead and we're going to put in ingredients. And the very first thing that we have to know is, again, the data must be bell-shaped. Data must, this is a big must, be bell-shaped. If it's bell-shaped, we can use the empirical rule. The only other thing we have to know is, just like Chebyshev, what's the average and standard deviation of the data set? So we're going to put in here, we must have the average and of the data set. Okay. Now, once we know the ingredients, what's the empirical rule telling us? We're going to talk about three particular pieces of it. The first is going to say about 65% of our data is within. About 65% of our data is within one standard deviation of the mean. And that's kind of like what Chebyshev was doing, but there's no more at least, there's no more minimum percentage this time. We're saying about 65% of that data will be within one standard deviation of the mean. Now, if we go further, like if we go 2 standard deviations from the mean, we're going further away from it. Should we find more data? Answer is absolutely. We're going to say about 95% within 2. About 95% of our data is within 2 standard deviations of the mean. And the third is, well, what would happen if we went up to 3 standard deviations? Before we were at 95% with 2. So what happens when we go to 3? At that point, we have just about everybody. So we're going to use a extremely tiny, minuscule amount of rounding and say 99%. So it's easy for us to remember the formula. And we're going to say, or not the formula, but the rule. And we're going to put in 3 standard deviations this time. Okay, so now that we know all that great stuff, let's go ahead and let's turn right away to an example. And on the bottom of the screen, it says the average flight between New York City and Miami is on average 120 minutes with a standard deviation of 10 minutes. If it is known that the distribution, the data distribution of flight times between these two cities is bell-shaped, find between which flight times we will obtain 65, 95, and 99% of all flights. Okay, so first thing is they had to tell us something, didn't they? Inside of this exercise, we had to know the data is bell-shaped. They told us that, so we know it's safe to use the empirical rule. And basically what they're trying to say is between what 2 time amounts, like between what 2 amounts of minutes are we going to find 65% of all flights, and then 95%, so on and so forth. And just to let you know, I really don't know what the distribution of data is, what it looks like between New York and Miami, what the average flight time exactly is. I'm just making all this up so it works. And we're going to go ahead. We're going to get ready to find the answer. So we're going to get ready for the first part. we're going to look for 65% of our data. And let's get set up here. Now, we know that at 65%, we're going to be within 1 standard deviation of the mean. So we're going to write down here low side, and we're going to take the mean, which is 120. We're going to subtract away 1 standard deviation. So 1 unit of 10, and we know that the standard deviation is 10 minutes. That's where we're getting the 10 from. And that's going to give us 110 minutes. To get the high side, the complement here, we're going to put in high, and we're going to do the same thing we did to get the low side, except we're going to use an addition sign this time. So we'll put in 120 plus 1 times 10, and that's going to give us 130. So now we know if you were to jump on a flight, it's going from New York to Miami, there's a 65% chance that your flight is going to last between 110 and 130 minutes. Let's go ahead and let's do the next break for 95%. And when we're working with 95%, this time it's saying we have to go to 2 standard deviations. So we're going to go ahead, we're going to prepare for the low side. We're going to write 120. And instead of 1 standard deviation, we want to subtract 2 standard deviations this time. So we're going to say 120 minus 2 times 10. That's going to give us 100. Now, of course, we need the high side again. Let's set up for the complement here. The high side, we're going to follow the same pattern, 120 plus 2 times 10. That's going to give us 140. Okay, so now we know if you got on the flight, there's a 95% chance that your flight is going to take between 100 and 140 minutes. And for the final piece, we need to find out, where are all the flights? Almost everybody, 99%. And let's get ready. What we're going to do is, we know inside of the exercise or inside of the empirical rule, the specification this time is 3 standard deviations. So we're going to say 120 minus 3 times 10, and that's going to give us 90. The high side, just like so, is going to give us 120 plus 3 times 10 is 150. So now we know almost everybody, 99% of all the people who make that flight are going to take between 90 and 150 minutes to make the journey. So I hope this video was helpful. What we're going to do in the next video is look at part 2 of the empirical rule. Thank you for watching Maverick Statistics. This is Jeff Mankowski.